Good morning, my dear students. My name is Dr. KCH Apparao, working as an associate professor in mechanical engineering department. Today, I would like to explain about definition, terminology, and types of heat exchangers. In heat exchangers, what are the different definitions and the terminologies on heat exchangers? We'll see. First of all, we'll see what is heat exchanger or defined heat exchanger. So it is a device to enhance the heat transfer rate. So the purpose of this, the application of heat exchanger varies in different areas. Heat exchanger is a system designed to transfer heat between fluids, mainly two fluids, only two fluids. Heat transfer takes place only in two fluids. So to transfer heat between two fluids to control the temperature of one of the fluid, the heat exchanger could remove thermal energy from a fluid used in air conditioning system or add thermal energy to a system. Just like remove the thermal energy from the system or add thermal energy to the system where process requires certain temperature to work properly. So finally it is a device to transfer heat or to enhance the rate of heat transfer as based upon the purpose. So there are so many types of the heat exchangers. So we can see the use of heat exchangers mainly in power generation plants like power plant engineering, power plants and nuclear power plants and steam power plants. Different power plants are there. Refrigerating system, air conditioning system, food processing system. In many areas, you can see in automobile sector also. We'll see. Now we'll see the types of heat exchanger. There are many types of heat exchangers based upon the fluid flow and flow directions. So based upon the design of heat exchangers, so many types of heat exchangers are there. These are the types of heat exchangers mainly. The first one is the direct contact heat exchangers. Second one is the indirect contact heat exchanger. So third one is the surface heat exchangers. So next one is the parallel fluid exchanger, counter fluid exchanger, cross flow heat exchanger. These three are very important. These three classifications are based upon the flow direction of flow of fluids and direction of the fluids. Okay. So next one is the shell and tube heat exchangers. So here we'll see the phase change also. Remaining all heat exchangers will see only heat transfer, not any type of phase changes. Next one is the compact type heat exchanger. These are the specially designed heat exchanger. We'll see what is the purpose of compact heat exchangers. So we'll see one by one what is direct contact heat exchanger, what is indirect contact heat exchanger, what is the purpose of surface heat exchangers, what is the functioning which are going in, uh, which is going in parallel fluid exchanger and design of counter fluid exchanger and cross fluid exchanger. What is the which is efficient compared to other also. We'll see one by one. The first one is the direct contact heat exchangers. In this direct contact heat exchangers means heat exchangers only heat will see heat exchange between only two fluids from hot fluid to cold fluid or cold fluid to hot hot fluid to cold fluid. Okay. So one fluid to another fluid or another fluid to just first next fluid. So only heat transfer takes place only between two fluid. two fluids. Here, so in the direct contact heat exchangers, both the fluids are in contact with each other. Then heat transfer takes place directly. You see, this is the direct contact heat exchanger. In direct contact heat exchangers, the heat exchange takes place by direct mixing of hot and cold fluid. Hot fluid, hot cold fluid, hot fluid and cold fluid. So only two fluids are there in heat exchanger. Okay. So heat transfer takes place from the hot fluid to cold fluid. Here heat transfer takes place by direct mixing of hot and cold fluid. Okay. So it involves heat transfer between hot and cold streams of two phases in the absence of separate wall. There is no separating wall or separating system. So both the fluids are contact directly. The heat transfer takes place. Here we can observe like this one. So, so this one is the stream of one fluid. This is the vapor of the another fluid. So these are direct contact with each other. So liquid fluid. This is the liquid. This is the vapor. The heat transfer takes place from the hot fluid to cold fluid by mixing directly. Okay. So here you can see these things. So we'll get the condensation by cooling the vapor with the help of water or fluid stream. Okay. So this is the one of the example for direct contact heat exchanger. So finally, in direct contact heat exchangers, heat transfer takes place from hot fluid to cold fluid. Both the streams may be different. So hot fluid and cold fluid the streams of two phases, different phases. So heat transfer takes place from hot fluid to cold fluid by mixing directly with each other. So this is the example. So next one, next one we'll see indirect contact heat exchanger. It is very familiar or most user type heat exchangers. Here, both the fluids are separated by some external pipes, some surfaces, some pipes. Otherwise, you can see here. So in this type of heat exchangers, the transfer of heat between two fluids, hot and cold fluid, could be carried out by transmission through a valve which separates the two fluids. So suppose this is the pipe and so this one is the cell on this one. Mhm. So one fluid that may be hot fluid or cold fluid, hot fluid flowing like this one. So cold fluid enters like this one, cold fluid. So both the fluids are separated by valve, but heat transfer takes place from the hot fluid to cold fluid by through valve. Here we can see uh, convection and conduction processes. Heat transfer takes place from fluid to pipe to cold fluid. Okay. So finally, heat transfer takes place from the hot fluid to cold fluid. So through a wall which separates the two fluid. So this is the very familiar type of heat exchangers. So indirect contact heat exchangers keep the fluids exchanging heat separately by the use of the either tubes or any pipes. Okay. So this is the very common type of heat exchangers. So in this also many types of heat exchangers are there, like parallel flow, counter flow, cross flow. All these are related to indirect contact heat exchangers. You can see. So already explained this one. Uh, this is the, you can assume this one is the cold fluid. So this is the hot fluid. Both the fluids are separated by pipes. So outer cell, this is the inner pipe. So heat transfer takes place from the hot fluid to cold fluid, hot fluid to cold fluid by through the wall which separates the both the fluids. Okay. So this is the uh, common type of heat exchangers, that is indirect contact heat exchangers. Okay. Now we'll see. So based upon the flow directions, there are three types of heat exchangers. One is the parallel flow heat exchanger, second one is the counter flow heat exchanger, and third one is the cross flow heat exchanger. These types of heat exchangers are very important and very familiar. Mainly these type of heat exchangers are used in many areas. The first one is the parallel flow heat exchanger. Second one is the counter flow heat exchanger. Third one is the cross flow heat exchanger. So we'll see what is the importance of these things, and we'll study mainly on these type of heat exchangers, mainly parallel fluid exchanger and counter fluid exchanger, cross fluid exchanger. So counter fluid exchanger and cross fluid exchanger, uh, both are same, but in case of cross fluid exchanger, we'll take some view factors and factors. We'll see first of all what is parallel fluid exchanger. Uh, what is the function of heat exchange in the parallel fluid exchanger, and what is the formula to derive the rate of heat transfer in parallel fluid exchanger also. Right? We'll see the first one, parallel flow heat exchanger. Suppose it is, these are nothing but indirect contact heat exchanger. Here both the fluid doesn't mix with each other. Those are separated by wall or surface, or wall surface is separate the two fluids. So this is the inner pipes. You can take, this is the hot fluid. So this is the outer cell. So parallel flow heat exchanger means both the fluids flow parallelly and in same direction also. So this is hot fluid. This one is the cold fluid. Okay. So cold fluids enters here and leaves from here. So cold fluid inlet to here, cold fluid outlet here. Okay. Similarly, hot fluid inlet here, hot fluid outlet here. Okay. So the flow direction of cold fluid also same, similar to hot fluid. Same direction, parallel to each other. So the fluids are flow in the same direction and parallel to each other. Those types of heat exchangers are called parallel fluid exchanger. Here, heat exchangers are classified based upon the flow directions. Okay. So this is called parallel flow heat exchanger. Okay. Parallel flow heat exchanger. You can see this diagram like this one. If you draw the graph, okay. This is the length of the heat exchanger. This is L. Hot fluid enters here, cold fluid enters here. Okay. So hot fluid temperature will be decreases, cold fluid temperature will be increases. Hot H naught, C naught. So because heat transfer takes place from the hot fluid to cold fluid, outlet temperature of cold fluid increases, outlet temperature of hot fluid will be decrease. So you can see this is the delta T1 is nothing but THI minus TC. Here we can observe this the inlet of hot and cold fluid are same direction, one direction or one side, and outlets of both the fluids, hot and cold fluids, and another side of the heat exchanger. Okay. So this is the delta T2. Delta T2 is equal to TH naught minus TC naught. These parameters are very important. Okay. So the final formula to find the rate of heat transfer through parallel flow, that is Q, is equal to UA into delta TLM. This is the logarithmic mean temperature, LMTD method. So we'll see what is LMTD method, what is the importance of that one also. UA into delta TLM means so delta T1 minus delta T2 by ln of delta T1 by delta T2. Okay. By using this formula, we can solve the rate of heat transfer. U is the overall heat transfer coefficient, and A is the area of the uh, heat exchanger. Delta Tm, this is the temperature differences. To find the rate of heat transfer through parallel flow, we require inlet and outlet temperatures of both the fluids. We require the HI, we require the H naught, we require the Ca, we require the C naught also. Without these parameters, we can't solve the rate of heat transfer through this method. Okay. If sometimes the outlet temperatures are not given, then you have to go to another method. We will see what is the importance of that one also. So this is the parallel flow definitions or heat exchanger. So this is the parallel flow. Once again, repeating, the parallel flow means here the both the fluids parallel to each other and flow in the same direction. This type of heat exchangers is nothing but parallel flow heat exchanger. So next one is the cross flow. As the name shows, so here it is very similar to parallel fluid exchanger, but flow direction is different. So here also you see this is the inner pipe, counter fluid exchanger. So H inlet to H outlet. Here just like in cold flow, cold fluid enters here, TCA, and leaves here, cold fluid outlet. Okay. So it means the direction of cold fluid is opposite to the direction of the hot fluid. So this is nothing but counter fluid exchanger. Counter fluid exchanger is both the fluids are parallel to each other, but in opposite direction, flows in opposite direction. So in parallel flow means both are parallel to each other, but in the same direction. But in counter flow, both the fluids are parallel to each other, but in opposite direction to each other. It means one side will see uh, hot fluid inlet to. You can draw the graph also like this one. So hot fluid inlet, same. Decreases hot fluid outlet. Okay. But the cold fluid enters here, another side, and hot fluid leaves, cold fluid leaves this section 1, 2. You consider this one, position 1. So cold fluid leaves here. Okay. It means, so this is the difference, means delta T1. Here delta T1 is equal to THI minus TC0. Okay. Here delta T2 is equal to TH0 minus TH0 minus TCA. Okay. So here just like one side outlet, cold fluid inlet and hot fluid inlet and cold fluid outlet. Another side cold fluid inlet and a hot fluid outlet. Okay. So inlets and outlets just different here, but in parallel flow, both the fluids inlets one side, both the fluids outlets and another side. But it is just opposite to parallel flow. Okay. So this is the cross flow heat exchanger. Then the rate of heat transfer in the cross flow. To find the rate of heat transfer in the cross flow, so this is the same formula according to LMTD method, UA into delta TLM, same. But delta TLM is different. Delta TLM is equal to same formula. Formula is same. Delta TLM is equal to delta T1 minus delta T2 by ln of delta T1 by delta T2. But T1 is different here. T1 is equal to delta T1 is equal to THA minus TC0. But in parallel flow, THA minus TCE. Delta T2 is equal to TH0 minus TCA. These two parameters. Here also, to find the rate of heat transfer in counter fluid exchanger, we require the four parameters. So inlet and outlet temperatures of cold fluid and inlet and outlet temperatures of hot fluid. Without these four temperatures, we can't solve the rate of heat transfer through LMTD method. Okay. So we'll see what is the importance of LMTD method and what is the drawback of LMTD method also. We'll see. So this one is the details regarding the terminology regarding the parallel flow and counter flow. Okay. Now we'll see cross flow also. Cross flow very similar to the formula to find the rate of heat transfer in the cross flow is very similar to counter fluid exchanger. Okay. Temperature varies, inlet temperature entering, outlet cold fluid entering, cold fluid leaving, hot fluid entering, hot fluid leaving. All these things are similar to counter fluid exchanger. Okay. So this is the, once again, just I'm repeating this one. In this type of heat exchanger, hot and cold fluid moves in the same direction, both cases. So direction is same, but both are parallel to each other. But in the same direction means, so that is parallel flow. In opposite direction means, so that is the counter flow. This is the diagram for the counter flow heat exchanger, parallel flow heat exchanger. This one is the diagram for the counter flow heat exchanger. Here, both the inlet temperatures of two fluids you can see here. Both the outlet temperatures of the two fluid you can see opposite side, just like end of the another side of the heat exchanger. Okay. So here hot fluid inlet to cold fluid outlet to here. Hot fluid outlet, cold fluid inlet is here. Okay. So both the fluids are parallel to each other and in the same direction here. That is called parallel fluid exchanger. So counter fluid exchanger means both the fluids are parallel to each other but in opposite direction. So this is the counter fluid exchanger. Now we'll see cross fluid exchanger. What is cross flow? The cross flow also here also the heat transfer takes place between two fluids, hot fluid and cold fluid. But the direction of two fluids are perpendicular to each other. Perpendicular to each other. So one fluid moves like this one, another fluid moves like this one, perpendicular to each other. Okay. So we'll see. That is called a cross fluid exchanger. Remaining temperature profile same, similar to the graph of cross flow. Hot fluid inlet to hot fluid outlet to cold fluid inlet to cold fluid outlet. So this is similar for finding of cross flow formula. So that one also same. Q is equal to F into, that is the factor. So how to find and how to add this one similar to UA into delta TLM. So remaining same. So this is similar to parallel flow counter fluid exchanger. UA F into U and A into delta T1 minus delta T2 by ln delta T1 by delta T2. Okay. So delta T1 which is similar to counter fluid exchanger, hot fluid inlet minus cold fluid outlet. Delta T2 hot fluid outlet minus cold fluid inlet, similar to counter fluid exchanger. Okay. So but here one thing you have to remember this one, view factor. That factor, shape factor, we have to add this one. So for finding of this one, we see when we discuss the numericals, how to solve this, how to find the value of f. We'll see in the numerical part. Okay. So this one is the cross fluid exchanger. We'll see definition of cross fluid exchanger. Cross flow means both the fluids flow perpendicular to each other, not parallel. Parallelity we'll see in parallel flow and counter flow. But here we'll see the direction of both the fluids are perpendicular to each other. Okay. That is cross fluid exchanger. In cross flow, we'll see some phase changes also. Okay. So in cross fluid exchanger, we have 90 degrees angles in the intersection of the two fluid directions. Okay. Perpendicularity. Okay. This type can include many channels and tubes which flow with 90 degrees pass over them. Let's see one example here. These are the examples of cross fluid exchanger. This one is the one fluid mixed, one fluid unmixed. So through this different tubes, we can pass fluids. Okay. This fluid doesn't mix it with the another pipe fluids, but on the cell, in the cell, that is the another fluid. So one fluid passing like this one, another fluid passing like this one, perpendicular. Okay. So this is the gas flow, that is the mixed fluid through pipes. Different fluids are not mixed with each other, so fluid is passing through the pipes. So here this condition is nothing but one mixed fluid and one fluid is unmixed. Here we'll see, here both the fluids are unmixed, so different cells are there. Through that cells, gas will flow through these pipes. One fluid, any fluid will flow. So there are many kinds of heat transfer cross flow heat exchangers. One is mixed, both the mixed fluids, not mixed, one mixed fluid, another is unmixed, both the fluid mixed, unmixed fluids. Okay, so we'll see one more. This is the shell and tube type heat exchanger. Okay. So this one also very important. So here we'll see condensation process also. It means phase changes also you can observe here. Okay. So it has, this is the cell. In the cell, many tubes are placed, or many tubes are designed. Through tubes, one fluid flows like this one. So through the cell, another fluid flows. So perpendicular to that fluid. Okay. So this is the flowing like this one. This one is the flowing up another fluid. Okay. So in this type of heat exchanger, one of the fluids move through a bundle of tubes, okay, by the shell. The other fluid is forced through cell. It moves over the outside surface of the pipes or tubes. Okay. So this one is the outside surfaces. This is shell and tube types. Sometimes we will see one cell and many tubes, and two cells and many tubes. So different shells, number also different, and tube numbers also different. So all these cases we'll see the functioning of cross flow heat exchangers. So both the fluids are perpendicular to each other. This is the type of shell and tube heat exchanger. Next, what is the difference between the heat exchanger and condenser? Okay. In the heat exchanger, we'll see only exchanging of heat, transferring of heat from hot body to hot fluid to cold fluid. But in condenser, we'll see the phase change also. Phase change along with the heat transfer. Okay. So that is called condenser. Condenser is also heat exchanger, but in a heat exchangers, in plain heat exchanger, we'll see only heat transfer, but in condenser, we'll see heat transfer along with the phase change. The main difference between these two are, so that in heat exchanger, only heat is transferred without phase change. Only heat is transferred without any phase change. But in condenser, heat is transferred along with the phase change. So that is the main difference between the heat transfer, heat exchanger, and condenser. Next, what is meant by open and closed heat exchanger? Okay, you know that open means so system in exchange of matter with the environment. So open to environment. So presenting import and export, building up and breaking down of materials, components. These are the open type heat exchanger. Closed system means that is those are held to be isolated from the environment. So exposed to, open to environment, and closed to environment. So based upon that principle, we can classify the heat exchangers in two types. One is the open heat exchanger, and another one is the closed type heat exchanger. Okay. So what is meant by regenerators? Regenerators. Okay. So in this type of heat exchanger, both the hot and cold fluids flow alternately through the same space. Okay. It is the hot body. First will flow hot fluid. Next will send cold fluid. So same space is alternately occupied by the fluids. Okay. So in this type, in this way, heat transfer takes place. Through hot fluid, the pipe will be heated. Through cold fluid, the heat will be taken from the hot pipe to cold fluid. So the main examples of this are IC engines and gas turbines. Different examples are there. Next, already we'll see what is the mean by recuperators. Recuperator. This is the most common type of heat exchangers here. It means already I explained that one for cross flow, parallel flow, and counter flow. These are the examples of recuperators. So this is the most common type of heat exchanger in which hot and cold fluid do not come in contact with each other, but is separated by a tube or wall or tube wall or any surface. Okay. So the examples of recuperators means the parallel fluid exchanger, counter fluid exchanger, and cross fluid exchangers. All these belongs to recuperators type of heat exchanger. Okay. Regenerators means, so already explained this one. Now we'll see what is the purpose of shell and tube heat exchangers also. We already discussed that one. In this in a two-phase heat exchanger, a liquid can be heated to the point that is boiled into a gas, or it may be used for the purpose of cooling a vapor so that it can be condensed into a liquid. So such phase typically takes place on the shell side of the shell and shell and tube heat exchanger. It means in shell and tube heat exchanger. So we'll see heat transfer along with the condensation, vapor condensation. Okay. So that is the main purpose. So we can these shell and tube type heat exchangers are used for the condensations. Okay. So next one, what is meant by compact type heat exchanger? Compact type heat exchanger, the specially designed type of heat exchanger where the high rate of heat transfer is required. We choose this type of heat exchangers, specially purposeful designed heat exchangers. Okay. So these are generally employed when the convective heat transfer coefficient associated with one of the fluid is much smaller than that associated with the other fluid. Okay. So one fluid convective heat transfer fluid is very less compared to other fluid. So in that case, we'll use this type of heat exchanger. Here in this compact type heat exchanger, area of heat exchanger will be increased more rapidly. Through that one, heat transfer rate will be increased rapidly. Okay. So these are the types of heat exchanger, different types and their definition and terminologies of those types. Okay. So these are the just different books. You can refer this one. Thank you for this listening this class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.